All right, good morning, everyone. Welcome to Coffee Break. Middle of May. If you're like me, had a my daughter graduated yesterday, so if anybody has some graduating children, congratulations to them. It was surely a fun day and very surreal. But today we got a great presenter, Sophia Roberto with Condair. She's going to be talking about adiabatic humidification and some good hospital certifications that Condair has. So Sophia, why don't you go ahead and take it away?
Perfect, thank you. Yeah, so as he noted, we'll be taking a look at humidification and adiabatics. First diving into the different humidification technologies before looking at specific adiabatic humidification for hospitals, going over our new energy analysis tool, as well as some current references to one of our products, the DL, that we currently see in hospitals. And we'll finish up with some key takeaways. So starting with humidification technology. When we look at humidification, we split this into two separate categories. First being isothermal. So this is where we're boiling water and forcing that phase change between liquid and vapor through the use of either introducing energy or gas to boil that water. Whereas adiabatic humidification, what we're doing is we're bringing in cold water and we're using the heat in the air to drive that phase change. So we're using the energy from the air. So we're not introducing any external energy sources. And so this can also be split into two separate categories. First, atomization. That's where you're typically pressurizing water through small nozzles or through small orifices to get water droplets or mist. And then the second is through evaporation. So that's where you're traditionally wetting a pad of media and running air across it to evaporate the water on that media pad. So at Condair, we have technologies for each category, looking into isothermal with our electric or gas units, as well as direct steam injection. And then we also have different technologies on the adiabatic side, a dehumidification line, and water treatment to complement all of our product line. But today we're going to be specifically focusing on the adiabatic line and those products that can be used under ASHRAE 170 into hospitals. So start taking a look now at adiabatic humidification for hospitals specifically. So why would we look at utilizing adiabatic systems? So first is the energy savings. Because we're not bringing in that energy in terms of electricity or gas to drive the phase change, you see a significant savings in the amount of energy that you need to produce each pound per hour. Another benefit to that is because we're using the heat energy from the air, we're actually taking that heat from the air and we're cooling it down. So this allows for even further savings when you're looking at economizer season, potentially extending your economizer season and turning off those mechanical chillers and allowing some of that cooling to come from the humidifier itself. Next is the flexibility of these systems. These are custom for each individual project that we work on. And so instead of being a boxed product where, for example, your maximum humidification load is 200 pounds per hour for this unit, and you need multiple if you have a higher load, we can customize these systems up to 2,200 pounds per hour off a single unit. And then we also see some advantages in terms of maintenance and new hygiene features that I'll touch upon a little bit shortly. So just looking again at that power consumption and the energy savings that you would see, this is an example of a load of 2,200 pounds per hour, where with an adiabatic system, we could run this off of a single unit versus a resistive element or an electrode system. You would need multiple units to make that load. And then you can also see the amount of power consumption that would require and the savings that you would see around 20 or 2,000 hours of operation. So looking at the different types of technologies a little bit more in depth, if we first look at what our ME series is, this is a unit that would not be allowed in hospitals under ASHRAE 170. It's a wetted pad media. So it's fiberglass that you then run water through, pass air across, and you're evaporating. But because you have a basin of water and you're recirculating that water and the pad is absorbing the water, that can pose a hygiene risk. So it's not allowed under ASHRAE 170. It is one of our most efficient adiabatic coolers. So you would be looking at this more so for the data center applications. We see a lot of these used to cool data centers. It does have a short absorption distance, but because we're relying on that padded media to fully saturate or fully dry out, it does have a larger swing in humidity control. You're looking at plus or minus 10%. So our first technology that would be used in hospitals is high pressure atomization, or what we call the HP series. So essentially what we're doing is we're pressurizing water to 1,000 PSI and then forcing it through nozzles with very, very small orifices to get a mist. Then we're spraying that for around 5 feet before we have a mist eliminator, just to ensure that we don't have any water carryover downstream. And with that, because we're spraying a specific amount of water, we know we get a much higher accuracy and controllability. So you're looking closer to plus or minus 2% RH. And then we have our third technology, which we'll be focusing on today. And this is what combines the two principles, atomization and evaporation. But the key difference here being that instead of a padded media, we use a ceramic media. So it's not absorbing any water. The water would sit on the surface and then evaporate. So to help with that hygiene level. So when we're looking to compare traditional high pressure, which has been around for over 50 years, versus the DL series, which this is something that is unique to Condair, we took a look at the HP and wanted to improve on some shortcomings that we saw when we designed the DL. So the first was the installation length. So with the HP, as I noted, it's about that 5 feet. With the DL, we look to shrink that significantly, and I'll touch on that in a second. Next is the energy efficiency. So with the high pressure, you're looking at 1,000 PSI, you need to have a high pressure pump in order to achieve that. With the DL, we're looking at a smaller pressure range up to about 100 PSI. Next is water waste. With the HP, because you're relying on that spray distance, we don't have that additional boost of the evaporation off the ceramics on the high pressure side. So you see a significant reduction in water wastage when you're looking at a DL series. Next is hygienic function, which I'll touch upon, and then the maintenance. So again, just having those high pressure components that those pumps would need rebuild, and there's more wear on the components because you're working at a much higher pressure. So looking specifically at the installation length, at high pressure requiring about 5 feet or more to get a well efficiency. So you're looking between 75 to 90% efficiency within that 5 or plus range. Whereas if we shrink that absorption distance down on a high pressure system closer to 24 inches like the DL, you're going to see a tank off in that efficiency closer to about 20 to 50%. So as you shrink that absorption distance on high pressure, you see a very big reduction in your water efficiency. You have to spray more to get your load absorbed. So with the DL, we're taking advantage of having that ceramic media. So we spray about 24 inches, and then any water that does not get absorbed in that first 24 inches will then evaporate off the ceramic. So you're seeing closer to a 95% water efficiency. Next, in terms of the hygiene, so both units have very good automatic flushing cycles. A key thing that we like to do with our units is ensure that there's no stagnant water, because that is what allows bacteria to multiply. And we took that one step further with our DL system, where we actively dose the unit, all the water that we're spraying with silver ion. So we know exactly how much water is being sprayed at a certain time, and we're precisely dosing with a certain amount of silver to make sure that we can effectively neutralize the germs or any bacteria that's present in the water, but we're not overdosing with silver. So what we also did with taking that even another step further is we had this third-party certified through the Fresenius Institute in Germany. So the Fresenius Institute is used to certify other medical technologies such as dialysis machines, and this is up to a hygiene standard. So they installed and ran our system for over 6 months of testing, and they purposely introduced different strains of bacteria into the water to see how the silver ion dosing system would be able to handle these different strains of bacteria. So after the months and months of testing, we were able to achieve their certification limits. So you can see here the amount of colony forming units that was found present in the water and the air was below their limits, and we were able to achieve the certification. So this is the only humidifier on the market that has this certification. Even our high pressure unit would not be able to achieve this level, and it's because of our silver ion dosing system. Taking a little bit of a look into ASHRAE 170. So ASHRAE 170 was changed in 2017 to allow pressurized water to be utilized in hospital settings for humidification. So prior to 2017, it was only allowed through isothermal means. Why did this change occur? So there was a key member on the board of ASHRAE 170 that was designing a new hospital where it was mandated that they had to reduce their electrical energy costs. So when taking a look at their building, the only way that they could see to do that was to look at their humidification systems. So the only way to do that reduction was to look at adiabatic humidification. So this is something that we see as being a major trend that will continue in the healthcare market, especially across the US, with decarbonization, electrification, and green buildings taking a forefront in a lot of designs. So with this in mind, there was two main goals that were kind of outlined in the standards of ASHRAE 170. So the first being no stagnant water. So water cannot sit in the feed lines in the feed lines for the humidifier to prevent any stagnant water in the unit. Again, that's where stagnant water is where bacteria have the ability to multiply and propagate through the system. And then the second is no Legionella. So ensuring that the units have proper drainage, proper temperature of the water to ensure that there's no Legionella that can be allowed through these systems. So with that, both the DL and the HP, we have systems. For example, the HP uses UV light as well as flushing systems to ensure that we're not risking any Legionella, and the same with the DL, but on top of that, we have the silver ion dosing system. Okay, taking a look into our energy analysis tool. So I can talk a little bit about how adiabatic humidification will save money in terms of energy usage, but we have to show that and prove that. So for the past around 3 years, Condair has been working with a consultant company to generate the first hour-by-hour energy simulation tool for adiabatic humidification. So this tool is available. It's offline. So if you do have a project where you're interested in looking at the amount of energy usage and the savings that could occur from comparing isothermal to an adiabatic technology, if you reach out to Long, they'll be able to work with us directly and we can provide a report based on some building input. And so I have an example here of a hospital that was done in Toronto, this in Toronto, Canada. So they were taking a look at replacing all of their current gas units with adiabatic technologies. So we took a look at the hour by hour, so looking at when the building is occupied, when it's not occupied, some of the setbacks, set points of different units, and then we're able to produce a full hour by hour simulation that included a report with several graphs and numbers to show the amount of energy usage and the dollar usage for their local utility rates. And then finally, taking a quick look at some DL references. The one that I like to highlight here is Sloan Kettering Memorial. This is in New York City. So this hospital actually installed a DL in their unit prior to that 2017 ASHRAE 170 change. One of the building owners was very familiar with the Fresenius Institute, so they had decided that knowing that certification and knowing the level of hygiene that it requires, that prior to ASHRAE 170, they were actually going to put in a DL into their unit. And then several other hospitals being the University of Maryland Medical, St. Jude's Cancer, Advanced Thermal Research, Parkland Memorial, which is a lab building, Atrium Health in North Carolina, and then Essentia in Duluth, Minnesota are all currently running DLs. And so up to date, I believe we have just over 90 DLs currently running in hospitals in the US. And then finishing this up with some key takeaways. So Condair, we do have a complete product portfolio. In every situation, adiabatic might not always be the best way to go. So we can take advantage of having that complete product portfolio, run an energy analysis, and see which technology is going to work best for your application. Adiabatic humidification in general does provide a more energy efficient humidification with free cooling, which can help to reduce your operational costs, and that there are many resources available. Your best resource being Long in Colorado. And then also on Condair.com, our website, we have several white papers and application resources, not just for hospitals, but for several applications that are free for everyone to use and read. Okay, Andrew, I'll give that back to you now.
Great. That is perfect, Sophia. You nailed it. Thank you very much. I hope that got some synapses going in your brains, and you guys and gals have questions about Condair and or adiabatic, especially in the hospitals with the certification that they have, could really be beneficial for everyone. if you do have questions, please reach out to your log sales engineer. We are all very, very happy to help. Join us next week. We got Chris Visconti. He's going to be introducing Pyroclast, which is integrated heat pump water heaters and, as you can see, the first in class heat pump boilers. $100 at REI, or the beer belt, which is cool, or the massaging chair, which is portable. You can take that anywhere you want. We do have a bunch of other prizes. So other than that, I think I forgot to say I'm Andrew Tobin. I am a sales engineer here. Thanks for joining us, and we will see you next week. Thank you.